in the part 4 of this module, we will talk about recommender system, and we will show how collaborative filtering based recommendation system is a form of instance based learning. So, first of all, let me introduce what we mean by a recommender system. Many of you have used e-commerce sites like Amazon, Flipkart and other sites, and you may have seen recommendation systems working. So, when you log into those systems, the system recommends certain items to you. So, a recommender system looks at the past behavior of the users and the other data that it has and tries to recommend items to the user. So, let us formally define a recommender system. There are two types of recommender system or recommending methods. One is item recommendation. That is based on the past history of this user and other users and maybe the type of the content. The recommender system recommends a list of items to the user which the user is likely to purchase or likely to consume. The second type of systems that we often look at are called rating prediction systems. The classic example is with movies. Suppose a user is asked to rate movies. The users rate movies, let us say in the scale of 1 to 5, and different users give ratings for different movies, but the set of total movies is very large and one user may give rating to a number of movies, few tens of movies. Now, the objective is to predict that given a new movie, what rating the user will give to that new movie. That is called the rating prediction problem. So, rating means rating on a new movie. So, predict. So, both of these are used to decide whether a person will hire a movie, buy a book, read a book, what new stories he will find attractive, recommend friends, etc. So, recommendation systems are ubiquitous in many e-commerce, almost all e-commerce systems have recommendation with them. Now, you are familiar with search. In search, the user is actively looking for something, user gives a query and the system returns results. So, user is trying to pull some information from the system. On the other hand, recommendation is a push system where the system pushes items to the user based on user's history and maybe based on the user's context also. Formally, we can define the recommendation problem as follows. So, we have a set of users U. So, U is the set of users and we have items. So, S is a set of items. And let P be an utility function that finds out the rating of a user for an item, the usefulness of an item to a user. So, P is a function from U cross S to, let us say, a real number, a rating. So, P is a function from U cross S to R, that is for a user, for an item, the rating of the user for that item, that is given by this function P. Now, the objective is to learn P from data. So, what is the training data? The training data is past ratings of the user for the rating prediction problem which we have written, or for the recommendation problem, past purchase history or consumption history of the user. So, we learn P from data and based on P we can predict the utility value of each item. Of each item to each user. This is the recommendation problem. Now, there are two broad types of recommendation systems: content based recommendation systems and collaborative clustering based recommendation system. In content based recommendation system, the rating prediction or recommendation is based on the content of the current item and the content of the previous items that the user recommended or liked. So, based on the similarity of the content of those items that the user liked and those that he discarded, we can try to predict whether the new item will be liked by the user or what rating the user will give to the new item. So, this is based on content similarity. For example, if you are trying to predict movies, trying to recommend movies to a user, look at the movies the user liked in the past, find out certain features about the movies. What was the genre, who was the director, who were the authors, who were the actors, location, etc. So, look at the important features of those movies and try to find out what features the user finds attractive, and based on that you try to predict which movies the user will like. The second type of recommendation systems are called collaborative filtering based systems. In collaborative filtering based system, the users, in order to predict movies for a user, we look at the what similar users liked. So, for a user, find similar users. Based on past data, we look at users who were similar to the current user. That is, if we know which movies this user liked and which movies the other users liked, find out the similar users. And if those similar users, so some of the similar users have given a rating for this movie, use those ratings to predict the rating of the current user. They are called collaborative filtering based method. And as we see that this involves finding similar users, which is what we did in K nearest neighbor or instance based learning. So, in collaborative filtering, we present each user. So we first construct our data. In our data, what we have is that we have suppose we have a matrix where the different items S1, S2, S3, S4, Sn, these are the columns, U1, U2, Um, these are the different users, and for a particular user may have rated some movies. Suppose this movie is rated as 5, this is not rated, this is not rated, this is rated as 2, this is rated as 3. For user 2, maybe this movie is rated as 3, this movie as 2, this is not rated, this is rated as 4. Similarly, we have for different users are presented with the movies, and they have rated some of the movies and they have not rated some of the movies. And what we want to do is that given a user item pair consisting of a movie which the user has not rated, try to predict the rating. For example, let us say U3 is another user who has rated 2, 2, 4, none. So, if we consider that U3 is a similar user to U2 and U3 has rated 4 for this movie, that will help you to decide what rating U2 will give this movie. This is the essence of collaborative filtering. Now, collaborative filtering, there are two types of collaborative filtering methods. One is based on user based nearest neighbor. As I told you that in collaborative filtering, nearest neighbor based methods are used to decide who are the similar users. So, in user based nearest neighbor, given a user, find similar users, use the ratings of the test item for those similar users to predict the rating of the test item for the new user. There is also item based nearest neighbor. In item based methods, the different items are compared. So, similarity between items are obtained by looking at who are the users who have rated, how the users have rated for the items. If there are two items which users have rated in a similar way, then those items are considered to be similar. This is an alternative to content based similarity of items. We can use this matrix, we can compare the column vectors to find out the pairwise item similarity, and we can use it for recommendation in this way. For a user, we look at those items the user has recommended, user has liked, and find out items which are similar to these items. So, for this item based collaborative filtering, which uses item nearest neighbors, can be used. So, for such algorithms, we have there are two phases to these algorithms. Look at this slide. First of all, we have to find the neighborhood. Let us look at user based nearest neighbor. In user based nearest neighbor, given a user and an item, we first look at the user and we find the similar users. So, this is the first phase of the algorithm, which is called the neighborhood formation phase. Suppose the record of the target user is u. The target user u is represented by a vector, and this vector is the rating that user gave to the items for which he has given the rating. So, the user is represented by this vector, and we find the similarity between the target user u and another potential neighbor v by using some similarity measure. A popular similarity measure is the Pearson's correlation coefficient. Pearson's correlation coefficient can be used to find the similarity between two vectors u and v, as in the numerator we have summation over all items, rating of u for item I minus RU bar is the average rating of the user for an item, times RVI, rating of user V for item I, minus RV bar, average rating of the user V. Now, why do we have RU bar and RV bar here? Now, different users have different standards for rating. There are some users who are reluctant to give a 5. You know, if the user likes a movie very much, he can give a 3 or at most a 4 and not a 5. And there are some users who are very liberal with ratings. So, they may give a rating of 5 to any movie that he likes. So, because users have different standards in rating movies, we want to somehow normalize them by looking at whether the rating of the movie is above his, how much it is more than his average rating. So, that is why in this formula we use sigma RUI minus RU bar times RVI time minus RV bar. RUI is the rating of user u for item I, and we sum it over all items. In the denominator we have root over summation over items RUI minus RU bar whole square times RVI minus RV bar whole square. So, this is for normalization, and this is one similarity measure. So, this type of similarity measure is used to score the similarity between two users u and v. After the similarity of u with all the users has been computed, we find the k nearest neighbors, that is k most similar users according to this formula. And the second phase is the recommendation phase. So, in the neighborhood formation phase, we find the similar users, and in the recommendation phase, we use the rating of those similar users on the test item to recommend the item to the user. So, for this, in the recommendation phase, we use the following formula to compute the rating prediction of item I for target user u. So, PUI is the predicted rating of user u for item I. It is equal to RU bar. RU bar again is the average rating of that user. We want to predict whether it will be below average or above average, and how much it will exceed or be different from the average. And this is computed as sigma V included in V. V is the set of neighbors, capital V is the set of nearest neighbors. So, for all neighbors, similarity UV is as we computed in the previous phase, times RVI minus RV bar. So, for a user V who is similar to user U, we look at the difference of the rating of V for I minus the average rating of that user. So, if the rating of item I for user V is greater than the average rating of that user, this is positive, otherwise it is negative. And the weight, this particular neighbor is given a weight based on how similar he is or she is to the user u. So, suppose we have a user u who is our target user and I is our target item. So, we find the neighbors, let us say V1, V2, V3, and they are the most similar users, and with each of them we have a value. Suppose with V1 we have a value 0.6, suppose with V2 we have a value 0.3, and V3 we have a value 0.25. Then we look at the prediction of the user V1 for item I, and we weight that by 0.6 by this similarity of V1 with U. We look at the rating of V2 for item I weighted by 0.3, look at the rating of V3 for item I weight by 0.25, and to overcome the bias factor, because different users have different standards of rating, everything we are doing in terms of the average as we see in this slide. So, please look at the slide again. So, we have PUI equal to RU bar, average rating of user u, times for all neighbors sim uv, for all neighbors v, sim uv times RVI minus RV bar, and in the denominator we have for all nearest neighbors the summation of the similarities. Okay. So, based on this we do our recommendation. Now, the similarity computed can be positive or negative. We took the look at the absolute value of the similarity in order to do this. So, this is collaborative filtering based recommendation system. So, CF stands for collaborative filtering. This is collaborative filtering based recommendation system using k nearest neighbor or user based k nearest neighbor. Okay. The problem of user based formulation of collaborative filtering is the lack of scalability. If you have many users in a popular sites like Amazon or Netflix, they can have many users, billions of users. Now, it is not possible in real time to find out the most similar users. because as we have seen, instance based learning algorithms, so these types of learning algorithms are lazy. At runtime you find the most similar users, and if the total number of users is very large, it is difficult without the use of good data structures to find the most similar users in runtime. And while several data structures, clustering, etc., can be used to make this more efficient, an alternative to user based nearest neighbor is item based nearest neighbor or item based collaborative filtering. In item based collaborative filtering, what we do is that we find similarity between the items. So, we compare the items. So, if you have two items I and j, the similarity between these two items are computed as, the formula is very similar to what we used for user based collaborative filtering. Here we sum over all users. We look at R u I minus R u bar times R u j minus R u bar. So, we look at the rating of user u for item I times the rating of user u for item j, and again we use the normalization, we subtract the mean for that user, and in the denominator we have root over sigma over all users R u I minus R u bar whole square times sigma over all users R u j minus R u bar whole square. Right. So, based on this we find the similarity between the items. Now, once we find the similarity of the items in the neighborhood formation phase, then we go to the recommendation phase. In the recommendation phase, we select a set of k most similar items to the target item. So, we have a target item I, and for the target item we find the most similar items. So, target item is I. We find the k most similar items I1, I2, Ik based on this formula that we have written, right, and then we do the rating prediction. The rating prediction is done PUI as sigma. I take the summation over the similar items. Capital J are the k similar items. We do R u j times the similarity of item I, item j divided by sigma j again over all neighboring items sim I j. So, based on this the rating is predicted. So, this is item based collaborative filtering. Okay. So, with this brief introduction we come to the end of recommendation systems, which is an application of k nearest neighbors, and we also come to an end of this module. After this the next module that we will start is on probabilities, Bayesian learning, naive Bayes and few such things. Of course, we will also have one class by our teaching assistant on how to use this nearest neighbor type in an instance based learning type of algorithms in some application. Thank you very much.